Hello everyone and welcome back to our Python programming course. I hope all of you have been practicing the programs from our previous lectures because today we are going to learn something very interesting. Before we start today's topic, let me ask you a simple question. In the last lecture, we learned about lists. A list can store multiple values in a single variable. For example, if I want to store the marks of 5 students, I can simply write, but before that, let's create a new file that is python lecture 9.py. So, as I said, we can create a list of student marks like 85 comma 90 90 comma 78 comma 88 comma 95. This is easy to understand. Now instead of creating 5 different variables, we store all the values inside one list. Now let me ask you another question. Can we change the values inside this list? The answer is yes. So we have already seen, but still let's prove it. So marks 0 is equals to, let's write 100. Now if I print marks, let's see the output. The output is 100, 90, 78, 88 and 95. Let's understand what is happening here. The value at the index 0 was 85. Now when I write marks as 0 is equals to 100, I am telling Python go to the first element of the list and replace its value with 100. Now we got the output as 100, 90, 78, 88 and 95. Notice that the original value has changed. This tells us something very important. Lists can be modified after they are created. In programming, we use a special word for this property. We say that lists are mutable. Now you might be thinking, if lists are mutable, if lists are already so useful, then why did Python create another collection called a tuple? That's exactly a very good question. Whenever you are learning programming, don't just ask how something works, also ask why it exists. Now, if we already have lists, why do we need tuples? Let's understand this with a real life example. Imagine you are filling out an online examination form. You enter your name, you enter your date of birth, you enter your Aadhaar number or registration number. Now, after you submit the form, are you supposed to change the details every day? Of course not. There are fixed details. These are fixed details. Now think about another example. Suppose you are booking a flight ticket. After your ticket is confirmed, details like your booking ID or ticket number should never change accidentally. Imagine the problems if someone could randomly modify those values. That would create complete confusion. So, in programming, there are many situations where we want to store information that should remain fixed. We don't want anyone to accidentally change it later. Now, Python provides a simple data structure for this purpose. That data structure is called tuple. So, here's a simple definition that I would like you to remember. A tuple is an ordered collection of items that cannot be changed after it is created. Notice that I used the words ordered collection. Ordered means the elements keep their position. If I store 5 values inside the tuple, the first value remains first, the second remains a second, and so on. The second important phrase is cannot be changed. Unlike lists, tuples are immutable. That means once a tuple is created, you cannot add any new elements, remove existing elements, or modify the values that already are stored inside it. This is the biggest difference between lists and tuples. Now let's learn how to create our very first tuple. The syntax is very simple. Type the following code with me. So student is equals to Rahul 20 comma computer science. Let's understand every part of the statement. First, we have created a variable named student. Now inside the variable, we are storing three values. The first value is a student's name. The second value is the student's age, and the third value is the student's course. Now notice something carefully. When we created a list, we used square brackets, but this time we are using round brackets that are also called parentheses. This is the most common way to create a tuple in Python. Now let's print the tuple. So print student, and now let's run the program. So the output is Rahul 20 computer science. Now that Python displays the tuple inside round brackets, that tells us the data has been stored as a tuple and not as a list. Now here's something interesting. Can a tuple store different types of data? The answer is yes. In this example itself, a tuple contains a string that is Rahul, an integer that is 20, and again a string that is computer science. Just like lists, tuples can store different data types together. Before we move ahead, I would like you to pause this video and try one small activity on your own. Now create a tuple that stores your own information. For example, your name, your age, your favorite programming language. And after creating the tuple, print it on the screen and make sure the output appears correctly. Now go ahead and try it yourself. Once you have done that, come back because in the next part, we're going to compare lists and tuples side by side. And you will clearly understand when to use a list and when to use a tuple, and when and and you will clearly understand when to use a list and when a tuple is the better choice. Now I hope you created your own tuple and printed it successfully. Now let's compare lists and tuples because this is where many beginners get confused. At first glance, both of them look very similar. Both can store multiple values. Both can store multiple values. Both can store different data types. Both preserve the order of elements. Both support indexing. Both support slicing. So naturally, a beginner asks, if they are so similar, why do we need both? That's exactly what we are going to answer now. Let's first create a list and a tuple containing the same values. So you can write the code with me. So let's write the code. Student list is equals to Rahul 20 computer science. Now let's create a tuple using the same data. So we'll copy this basically and we'll going to paste it. So student tuple. Take a moment to look carefully at these two lines. Can you spot the only visible difference? Exactly. The list uses square brackets while the tuple uses round brackets. At this point, they almost seemed identical. Now let's print both of them. Student list and then print student tuple. Let's run the program and we'll see the values are exactly the same, only the brackets are different. But the real difference is not the brackets. The real difference is what Python allows us to do with them. Let's begin with the list. Suppose Rahul has changed his course from computer science to artificial intelligence. Can we update the list? Absolutely. Let's write the code for that. So student list 2 is equals to artificial intelligence. Now let's print the student list. Let's understand this line carefully. Now here we can see that computer science has been changed to artificial intelligence. Now let's understand this line carefully. Student list 2 means go to index number 2. Remember, indexing starts from 0. So let's count. Index 0 contains 0. Index 0 contains Rahul. Index 1 contains 20 and index 2 contains computer science. So Python goes to the third element and replaces it with the new values. Now run the program. So again if I run this, the output we get is artificial intelligence instead of computer science. Now let's try the same thing with the tuple. So if I write student tuple is equals to artificial intelligence and then try to print. Now student tuple. Now before running the program, I want you to stop for a moment. Don't press run yet. Instead try to answer this question. What do you think will happen? Will Python allow us to change the values? Or will it ignore the statement? Or will it produce an error? Now let's run the program. Now let's run the program. Immediately Python gives us an error. The error message says that tuples do not support item assignment. Now don't get scared by the wording of the error. Now let's understand it in simple English. Python is basically saying you are trying to change something that is not allowed to change. That's all. This happens because tuples are immutable. Once a tuple is created, its elements cannot be modified. This is the most important property of tuples. If you remember only one thing from today's lecture, remember this. Lists are mutable while tuples are immutable. Now, Now let's repeat it once more because it's extremely important. Lists can be changed, tuples cannot be changed. Now let me ask you another question. If tuples cannot be changed, then why would anyone use them? Isn't that a disadvantage? Actually, no. In many situations, immutability is an advantage. Let's understand with another real life example. Imagine your college issues. You are Imagine your college issues your registration number. For example, 12409876. Should this number change every week? No, it is changed. If it changed regularly, your attendance records, examination records, and fee records would all become incorrect. Similarly, think about your date of birth. Once recorded correctly, it should never change. Think about a train ticket number. Think about a passport number. Or think about an Aadhaar number. These are examples of information that should remain fixed. Now, when data should remain constant throughout the program, a tuple becomes a better choice than a list. Now, here's another benefit. Because tuples cannot be modified, Python can handle them more efficiently in many situations. You don't have to memorize the technical details right now. Just remember this simple idea. If the data will change frequently, use a list. If the data should remain fixed, consider using a tuple. That simple rule will help you choose the right collection in most beginner programs. Now let's see another interesting feature of tuples. Can a tuple store different kinds of data? The answer is yes. Let's create another example. Now employee is equals to Rohit Sharma. Age is 28. Salary is 55,000.50, and last one is true. Let's understand each value one by one. So the first value is a string, it stores the employee's name. The second value is an integer, it stores the employee's age. The third value is a floating point number and it stores the employee's salary. And the last one is a boolean value which tells us whether the employee is currently active. Now let's print the tuple by print employee. The output displays all four values together inside parentheses. This example proves something important. A tuple is not restricted to only one data type. It can store strings, integers, floating point numbers, boolean values and many other data types together. This makes tuple very flexible while still keep the data protected from accidental modification. Now that we know that tuples are and why they exist, the next question naturally becomes, how do we access the values stored inside a tuple? Do we use indexing just like lists? Or does Python provide a completely different method? Let's find out. Let's find out. Now that we know what tuples are and why they exist, let's answer the question we just asked. How do we access the elements stored inside a tuple? Well, if you have learned lists properly, then I have some good news for you. Accessing elements in a tuple is almost exactly the same as accessing elements in a list. Python doesn't introduce a completely new concept here. Instead, it refuses the same indexing concept that we have already learned. Instead, it reuses the same indexing concept that we have already learned. And that's actually a good thing because it means you don't have to learn everything from scratch. Let's understand this practically. Now, create a tuple with me, that is student is equals to Rahul, comma 20, comma computer science. Now, let's not rush to the next line. First, let's understand. Okay, I'm so sorry. So, let's understand what we have just created. This tuple consists of three different pieces of information about a student. The first element stores the student's name, the second element stores the student age, and the last element stores the student course. Now, just like list, every element in the tuple has its own position. That position is called the index. Now, the element Rahul is stored in the index 0, the element 20 is stored in the index 1, and the element computer science is stored in 2. The indexing starts from 0. This is exactly the same rule that we learned while studying list and strings. If you are still not comfortable with 0 based indexing, don't worry. It becomes very natural after writing a few programs. Now let's access the first element. So we'll write print student 0. I want you to predict the output. Don't just wait for me to execute the code because programming is learned by thinking first and running later. So what do you think the output will be? Will Python print the complete tuple? Will it print the number 20 or will it print Rahul? Now let's run the program. Now the output is Rahul. Exactly. Python looked at index number 0 and returned the value stored there. Now let's print the second element, that is 20. So here we'll write 1 and let's see the output, and yes. Index 1 stores the age. So when we run the program, the output becomes 20. Now let's print the course. So if I write 2 instead of 1, the course computer science gets printed. And finally, we got our output. Now let's stop coding for a moment and observe something. Did you notice that we never had to search for the values? Python already knows exactly where every element is stored. When we write an index, Python directly goes to that position and returns the value. This is one of the reasons indexing is extremely fast. Now I have another question for you. Suppose I accidentally write this. Print student 5. Now think carefully. How many elements are present in our tuple? Let's count. Rahul, 20 and computer science. So that's only 3 elements. The indexes are 0, 1, 2. Now ask yourself, does index number 5 even exist? No. So what do you think Python will do? Will it print nothing? Will it print 0 or will it produce an error? Let's find out. Immediately Python displays an error. The error is index error, tuple index out of range. Don't be afraid of this message. The error is actually helping us. Python is simply saying, you asked me for an element that doesn't exist. Whenever you see an index error, the first thing you should think, the first thing you should check is whether the index you are using is valid. Most beginners think the error means Python is broken, but in reality, the mistake is usually just an incorrect index. Now, here's a small exercise for you. So, pause the video and try answering these questions without running the code. So, the first question is cities is equals to Delhi, Mumbai, Kolkata, and let's say Chennai. Now, what will be the output if I write print cities 0? If you have guessed it, guess the second one, that is print cities 2. And what if I write print cities 3? Now the last one, print cities 4. Now let's see by running this. So at first we got Delhi, the second we got Kolkata, and the third we got Chennai. So that's what we were expecting from the first three. But the last one we gave index 4, which is not present in the tuple. So we got an index error. So if you answered all the 4 correctly, it means you have understood tuple indexing. But Python has another very useful feature that makes accessing elements even easier. Until now, we have always counted from the beginning of the tuple. But what if I want the last element or the second last element? Do I always have to calculate the last index? Fortunately, the answer is no. Python gives us something called negative indexing. And once you learn it, you'll use it in almost every Python project. Let's understand that. Now that we have understood positive indexing, let's learn about another useful concept called negative indexing. Positive indexing starts counting from the beginning of the tuple. But what if I want to access the last element? Do I always need to calculate its index? The answer is no. Python provides negative indexing, which starts counting from the end. Let's use the same tuples as before. So students is equals to Rahul 20 and computer science, and let's say college. Now the positive indexes are 0, 1, 2 and 3. So 0 is Rahul, 1 is 20, 3 is college and second is computer science. Always remember one simple rule, that last element is always -1, the second last element is -2. So the negative indexes are college -1, computer science -2, 20 -3 and Rahul -4. Now let's print the last element. So print students -1. So let's see the output. Yes, so we get college. Now if I write print college -2, what will be the output then? Now if I write print students -2, what would be the output then? The output would be computer science. And if I write print students -4, now what will be the output? The output will be Rahul. So whether you use positive indexing or negative indexing, Python still accesses the same data. You are simply choosing a different direction to count. Negative indexing becomes very useful when you are interested in the last few elements of a collection. For example, imagine you store the temperature of the last 7 days in a tuple. If you want today's temperature, you don't need to know how many values are stored. You can simply write temperature minus 1. This makes your code cleaner and easier to understand. Now let's move to another important concept, slicing. Until now, we have accessed one element at a time. But suppose I want multiple elements together. For example, I want only the first two values. Should I write two separate print statements? Of course not. Python provides a feature called slicing. The syntax is tuple name. So let's firstly remove this. So the syntax goes like tuple name, start and stop. Remember that the most important rule, the start index is included but the stop index is excluded. Let's see this with an example. So print students 0 is to 2. Now let's see what's the output, but we should remove this for zero confusion. So let's see. The output is Rahul and 20. Notice that the output is still enclosed inside parentheses. That's because slicing a tuple returns another tuple. Now let's try another example. Let's try print students 1 is to 4. Now can you guess what's the output? The output should be 20 computer science and college. Here's another useful shortcut. If you omit the starting index like I'm doing over here, see we have omitted the starting index. Python continues until the last element. If you omit the starting index, Python automatically starts from index 0. Similarly, if you omit the index at the ending or the ending index, Python continues until the last element. These shortcuts are very important in real Python programs, so try to remember them. Let's finish this section with one quick question. What do you think will be the output of this print students? Can you guess the output of this? So let's check it. When both the start and stop indexes are emitted, Python selects the entire tuple. So the output is Rahul 20 computer science and college. In other words, Python returns the complete tuple now. Complete tuple. In other words, Python returns the complete tuple. Now that we know how to access one element and multiple elements, the next step is to learn some built-in operations that work with tuples, such as checking whether an element existing, counting occurrences, and finding the position of an element. Let's look at another simple but very useful operation that we perform quite often. Suppose I want to check whether a particular value exists inside a tuple. Now, how we will check? Let's see. So, this is my tuple, and now suppose I want to know whether college is present in the tuple. One way would be to check every element manually. We could compare the first element, then the second element, then the third, and finally the fourth. But that isn't efficient. Python gives us a much easier solution called the membership operator. There are two membership operators in Python. The first one is in, the second one is not in. We have studied both in the concept when we were understanding string. Now let's understand the first one. So let's write print college in students. Now let's predict the answer before running the program. In this word college, is this word college present inside the tuple? Yes. So Python should return 2. True. So let's run it. And yes, it returns true. Noticed that the output is not college. It is also not the index of college. Instead, Python simply answers the question we asked. The question was, does this value exist inside the tuple? Since the answer is yes, Python prints true. Now let's try another example. So instead of college, if I write Delhi, again think before running. Is this word Delhi present anywhere inside the tuple? No. So the output should be false. Very simple. Whenever the element exists, Python returns true. If it doesn't exist, Python returns false. Now let's understand the second membership operator. Instead of checking whether an element exists, sometimes we want to check whether an element does not exist. For that, Python provides not in. Let's write the code. So if I write Delhi not in students, we already know Delhi is not present. So this statement should result true. And yes, we get true. Now let's try one more example. Now if I write Rahul instead of Delhi, this time Rahul is present. So the answer becomes correct. So the answer becomes false. So always remember these two operators. In asks is this element present, and not in ask if this element is not present. These operators are extremely common in real Python programs. For example, you might check whether a username already exists, whether a product is available, or whether a particular city is present in a list of delivery location. Now let's quickly revise everything we have learned about tuples so far. We learned how to create tuples, we learned positive indexing, we learned negative indexing, we learned slicing. And now we have learned how to check whether an element exists using the membership operators. At this point, you already know enough to use tuples in many beginner level programs. But Python also provides a few built-in methods that make working with tuples even easier. Fortunately, there are only two methods that every beginner needs to know. That means they are very easy to learn. In the next part of this video, we will study the count method and the index method with practical examples and understand where they are useful in real programs. Now, so far we have learned that tuples are immutable. We have also learned how to access elements using indexing and slicing. Now, the good news is that there are only two functions. Unlike lists which have many methods, tuples only have count and index. The reason is simple. Remember, tuples cannot be modified. So methods like append, remove or sort doesn't exist for tuples. Let's understand the first method, the count method. Imagine a teacher conducted a survey in a class. Every student was asked to choose their favorite programming language. The response was stored in a tuple. Let's create a tuple. So, languages is equals to Python, Java, and then again Python, then C++, then Python again, then lastly it's Java. So let's give the parenthesis. So here is the tuple. Now let's print the tuple first. So if I write print languages, let's see the output. Now suppose the teacher asks, how many students selected Python? Of course we can count manually, but Python provides a much easier way. Write the following with write the following statement with me. So print languages dot count Python. Before running it, let's think. How many times does the word Python appear? Let's count together. First position, third position, and the fifth position. Now that makes a total of 3 times. Now run the program. Let's see what's the output. Exactly as expected. The count method counts how many times a particular value inside the tuple appears. Now, now let me ask you a question. What happens if we search for a value that doesn't exist? So instead of Python, if I write JavaScript, let's see what's the output. 0. Python does not produce an error. Instead, it simply tells us that the value appears 0 times. This makes count very safe to use. Whenever you need to know how many times something appears, count is the perfect choice. Now let's move to the second method, that is the index method. Suppose the teacher now asks with another question. At what position does C++ appear for the first time? This time we don't want the total count, we want the position. For that, Python provides the index method. So you can write this code with me. So if I write index and C++ over here, before running the program, let's look at the tuple again. So Python, Java, Python, C++, Python and Java. So indexes are 0, 1, 2, 3, 4 and 5. Now C++ is stored at index number 2. So C++ is stored in index number 3. Now let's see exactly. The index method returns the position of the first occurrence of an element. Let's understand why I stretched the words. Let's understand why I stressed the words first occurrence. Look at our tuple once again. The word Python appears 3 times. Now write print languages dot index Python. The output is 0. Now some beginners expect the answer to be 2 or 4. That's not how index works. It always returns the position of the first matching element. As soon as Python finds the first occurrence, it stops searching. Now let's intentionally make a mistake. Type HTML instead of Python. Now what do you think will happen? HTML isn't present anywhere inside the tuple. So let's run it. And Python displays a value error. Why? Because unlike count, which simply returns 0, the index method expects the value to be present in the tuple. In Python, if Python cannot find the value, it raises an error. So here's a simple rule to remember. Use count method when you want to know how many times something appears. Use index when you want to know where something appears. Don't confuse between these two methods. They solve completely two different problems. Now let's test our understanding with a few questions. So the first question is fruits is equals to apple, then mango, then again I am writing apple, and at last I am going to write orange. So this is my tuple, and if I print fruits dot count, let's say apple, now can you predict the output of this? The output should be 2 because apple appears twice. Now second, what if I write print fruits dot index orange? Now can you predict the output? Think carefully. Orange is at index 3, so the output should be so the output should be 3. Now we know every important tuple method that beginners use. Uh, we know every important tuple method that beginners use. In the upcoming part, we'll learn some interesting tuple operations like combining tuples, repeating tuples, packing, unpacking, and finally build a small project to see where tuples are actually used in real programs. Now that we have learned the two built-in methods of tuples, let's explore a few useful operations that we can perform on them. The first operation is called tuple concatenation. The word concatenate simply means to join two things together. Now that we have learned the two built-in methods of tuple, let's explore a few useful operations. The first operation is called tuple concatenation. The word concatenation simply means to join two things together. Suppose one tuple stores the names of students from section A and another tuple stores the name of students from section B. Let's create those both tuples. So section A is equals to Rahul, Aman, and then Priya. Now we'll see section B is equals to Priya, Karan, and then Neha. Now imagine that the school wants a single attendance list containing students from both the sections. Instead of typing every name again, Python allows us to join both tuples using the plus operator. Now type the following code with me. So all students is equals to section A plus section B. Now if I print all students, let's understand what happens here. Python first takes every element from section B, then it takes every element from section B. Then finally it creates a new tuple containing all the elements. Now let's run the program and we'll see what's the output. The output becomes Rahul, Aman, Priya, Riya, Karan, and Neha. Notice something carefully. Neither section A nor section B has changed. Instead, Python has created a new tuple called all students. This is important because tuples are immutable. Python cannot modify the original tuples, so it creates a brand new tuple instead. Now let's look at another operation called repetition. Suppose you are designing the seating arrangement of an examination hall. Each row contains the same three seats label, row A, B, and C. Instead of writing the same tuple again and again, we can use the multiplication operator. Now, let's understand that too with a simple program. So, row is equals to A, comma, B, comma, C. Now, if I print row into 3, can you predict the output? So let's see. The output becomes ABC, ABC, and ABC. Now Python has repeated the entire tuple 3 times. This operation is called tuple repetition. Let's try another example. So numbers is equals to 1 comma 2. Now if I print number into 5, let's see the output. So the output is 1 2 1 2 1 2 1 2 and 1 2. Again Python repeats the complete tuple 5 times. Remember one thing, the multiplication operator here is not performing mathematical multiplication. It is simply repeating the tuple. Now let me ask you a quick question. What do you think will happen if I write numbers plus row? Will Python allow it? Let's test it. Python gives an error. Why? Because number contains integers while row contains now. Will this actually give an output? And yes, we get the output. Tuples can contain mixed data types. So concatenating this to tuple works because both operands are tuples. Let's correct our understanding by running the code again. So what's the actual rule? The data type inside the tuple do not matter. The important thing is that both operands must be tuple. For example, if I write like this, so numbers is equals to 1 2 3, but if I write A, comma, B, comma, C. Now here the first object is a tuple but the second object is a list. Since Python cannot combine a tuple with a list using the plus operator, it raises a type error. So remember this rule. If you concatenate a tuple with a tuple, it is allowed. but a tuple plus list not allowed. This is another common mistake that beginners make. Now we have learned how to join tuples, repeat tuples. Now we will be learning two very interesting topics called packing and unpacking. These features make Python code shorter, cleaner, and are used extensively in real world programs.